Hi everyone, I am here with one new problem on prime numbers. So this is nothing but finding nth prime. What is meant by nth prime? So when n is given as input, for example say 5, we have to produce the fifth prime number. So how to get this fifth prime number? So the first prime number we all know is 2, the second prime number is 3, the third prime number is 5, fourth prime number is 7 and fifth prime number is 11. Okay, so this should be the output for the given input 5. So the output for this problem should be 11. Okay, so this we have to produce. So for this one, what is the logic we need to follow? So first I will be writing a function to check if a number is prime or not. Okay, that is the first thing. The next thing is I will write another function to find nth prime. Nth prime. So what is the logic for this one? So the first one we all know how to check whether the given number is prime or not. I have explained in another video, you can watch that one. So the second step is function to find nth prime. So how to find this nth prime? So initially I will assume the nth prime np as 2. Initially I will start with the first prime, that is 2. Count count is to be set to 0 and I will be taking one I. This I will help me to go up to nth prime. So I will start this I with 2. Then from I equal to 2 onwards, I will be checking whether this I is prime or not. I is prime or not. If I is prime, set np to I. If I is prime, set np to I and increment count by 1. Okay, so otherwise repeat in the loop and increment I by 1, I equal to I plus equal to 1, and then repeat the loop, and at one point this count will become equal to n. Count equal to n. There you stop the procedure and print the or return latest prime, that is np. Okay, this is the logic. Now I will write two functions for this one to check whether the given number is prime or not and another one to generate nth prime. Then so this nth prime will be called from main function. We will read n, then we will generate nth prime. We will call the function nth prime of n. Okay, so this will give the output. That is the logic to be followed. Okay, so I hope you understood this logic, and let us implement that in various programming languages. Here I am going to consider Python, Java code and C# code. In Python, first I am writing one function by name isPrime. So if you know the routine logic of this checking whether the given number is prime or not. This is the efficient logic which gives the time complexity big O of square root of n. So to check whether n is prime or not. Okay, this is the efficient approach compared to all other approaches. Okay, so I am implementing that. If n is less than 2, return false. That means if n is 0 or 1, that could not be a prime number, and then return false. Then start I with 2, then we will be considering square root of n. So instead of writing square root of n, I am doing it in a reverse manner. While this I square is less than or equal to n, this is equivalent to I less than or equal to square root of n. Okay, the equivalent statement I am writing like this. I square less than or equal to n if n% I equal to 0. That means if n is divisible by any I value, that can't be a prime number. So return false. So otherwise increment I by 1 and proceed until this I reaches square root of n. Then after that return true. That means we could not find any factors below that number. Return true. True means the given number is prime. So this is the logic to check whether the given number is prime or not. We wrote one function for that. What is the name of that function? E is prime and it is taking one parameter n. Next, let us define the function nth prime of n. So nth prime is like, as I told you already, if n is given as 5, we should produce the output as 11. That is nth prime. Then initialize nth prime to 2. We all know that the prime numbers start from 2. Then set I to 2. Below that even you can set I equal to 0, but it is not necessary. I equal to 0 means again until it comes to 2, the 2 iterations will be commenced, and that is waste of time. As we are clear that the first number starts with 2, the first prime number starts with 2, let us directly initialize I to 2. Then count equal to 0. So I am considering one unconditional while statement here. Unconditional in the sense, without checking any condition, we are allowing the control to enter into the loop. So while true, if count equal to n, return np. That means nth prime. Count equal to n means we got the nth prime number and that nth prime number is stored in np. Return that one. Otherwise, check whether this I is prime or not. If I is prime, set nth prime to I and increment count by 1. Why we are incrementing count by 1? We got one prime number. We are updating the count by 1. Then at one stage we have to see that whether this count is equal to n or not. At that time we have to stop. Otherwise we have to repeat the process. Increment I value by 1. And when this while loop will stop, so this is the exit condition for this while loop. If count becomes equal to n, then we have to stop. Then in main function, we are reading the input from the user. That means n value is read, and we are calling the function nth prime. Nth prime, and what is the parameter? N. Suppose this n is 5, we are calling this nth prime of 5, and what will be the return value for this one? 11. That will be printed. Okay, so this is the logic for finding nth prime. The first step is write a function to check whether the given number is prime or not. The second step is write a function for finding nth prime, and what is the logic involved in that function? Take three variables np, I and count. So initially set np to 2, I to 0 or anything, but it will actually start with 2. Then initialize count with 0. Then write one unconditional while statement, and this unconditional while statement should exit when count becomes n. Otherwise we will check whether each I is prime or not. If it is prime, what is the logic to be implemented? If it is prime, set the nth prime to I and increment count by 1. Okay. So this is how we must proceed. So this is the Python code, and I wrote the same logic in Java also. So the Java logic goes like this: finding nth prime, import, as we need to take input, import this util.scanner. Then we are writing one class. As Java is strictly object oriented, all the code must be enclosed within one main class, and the name of this file must also be nth prime dot java. This file is to be saved as nth prime dot java. Okay, Python is not purely object oriented, that's why I have written like ordinary C program. Okay, so but in Java we must write everything within the class. Then I am writing one function. I am designating that function as static. Why? Because I am not going to create object and I will directly call is prime. Static boolean. What is the return type of this function? Boolean, true or false. Is prime int n. The same logic which I have written in Python code is written over here. So if n less than 2, return false. Then set I to 2 and continue up to I less than or equal to square root of n. Then if any number is dividing n exactly, return false. Otherwise proceed, increment I by 1 in each iteration. Then finally, if we cannot return false, return true. That means the given number is prime. So this is the logic for checking whether the given number is prime or not. As I told you already, this is an efficient approach which consumes big O of square root of n time complexity. Next, I am writing another function, nth prime. So what is the signature for this function? Static. Return type is long. I am considering intentionally, I am considering very large number that may be returned as nth prime. So that's why I considered long, and it takes one parameter whose type is integer. As I said earlier, np is to be initialized to 2, count is to be initialized to 0, I to be initialized to 2. While true, this is again unconditional while loop. When this loop will exit, when count equals to n. Okay, then check whether each I is prime or not. If it is prime, update this np to I and increment count by 1. That means we got one new prime number, increment count by 1 and increment I value by 1, and this will be continued until this count becomes n. Okay, so as we don't know what may be the value of this n, as there are no boundaries given to us, then we will be running one unconditional loop, and when the conditions meet, we will exit from the loop. Okay, then in main, we are creating one scanner object to take input. I think you are all familiar with this usage of scanner object. We are creating one SC object. Through this one, we will be reading one integer. System.out.println, enter n. Then sc.nextInt. NextInt will read one integer from the user, and that will be stored in n. Then call this nth prime and print it instantly. Okay, so this will print, suppose if n is given as 5, this will print 11. Okay, next, similarly I have written C sharp code. C sharp code is more or less same as Java, except some statements like console.write line, console.read line, remaining all are almost same. So we must use this using system at the beginning. Then like Java program, we have to put all the statements in one class, that is nth prime. Here we need not save the program as nth prime.cs. That is not compulsory in C sharp. Okay, then static bool. Bool is the boolean data type in C sharp, and remaining all is very same as our Java code. Okay, next, similarly I am writing another function by name static long nth prime, and its return type is long here also, and updating initializing np to 2, count to 0 and I to 2, then writing one unconditional while statement. Then when count equal to n, it will exit from the loop. This is also very same as Java code. And where can we find the difference with the Java is, in Java we use small m for main, and here we use it as capital M. That is one difference. And instead of system.out.println, we are using console.writeLine, and instead of nextInt or something, we are reading and we are converting it to integer in C sharp. It reads input that will be basically in the form of string, and that is explicitly converted to integer. So what is the method to convert string to integer? Int.parse. Okay, it converts it to integer, and that is stored in n. Then we will be calling this nth prime function with the n value as input, and we are displaying the output instantly. Okay, so this is the C sharp code. Okay, so suppose if you would like to have the code, you can pause the video and you can have a look at the code. I will also show you how to execute these codes. Okay, so first let me start with Python code. So this is the code which I have explained earlier. I will run this code with the different inputs. Run, enter n. First I will be giving first prime number. What is the first prime number? 2. I am sorry that th is displayed here. Next I will be running it again. Second prime number, that is 3. Then I will be giving fifth prime number, that is 11. Okay, it is working perfect. Similarly, let me show the Java code. Oh, sorry. I think I have erased Java code. I can copy it from here. Yeah, let me run this one. It is asking for n. I will be giving this as 4. What is the nth prime number? 7. It is working perfect. Let me run with the C# code. Yeah, this is the code I have explained in the document. Let me run this one. Enter n. Let me give this as 6. I should get 13. Yes, it is working perfect. Okay. So I hope you understood the logic. If you understood the logic, hit like button, share it with your friends and subscribe. Thank you.